All right, here we go, guys. 1.2, transformations of linear and absolute value functions. You will need your sheet, your chart that I gave you. Okay, you will need that out. We'll be looking at this. Okay, and we will be taking a look first. Today we're just doing linear and absolute value functions. Excuse me. We will be taking a look first at our horizontal translations and vertical translations. So take a quick look there on your chart and notice that horizontal translations, I'm changing what in my function? I'm going left and right. In my function, am I changing everything or just the x? Just the x. Notice that says inputs. You guys learned clear back when, like I talked about with your input-output machines, inputs are your x values. Okay? And your vertical translation, you are changing your outputs, which is y, which is everything, basically. Okay? So, taking a look here at example 1, I'm going to do a different one than they have, but it's similar. They give me my original function, f of x equal to 4x minus 9. Okay, so that's where I'm starting. They then want me for part A, they want me to take that function and write a new function, g of x, that is a translation 5 units up from this graph. Okay, so when we're doing this, I want you to take and my Swivl's not working right, so I got to do it manually. Rewrite everything. Okay, well we know a vertical translation is moving it up and down. So, and I want to go 5 units up, right? So I have to add 5 where? Yeah, to the very end, to the whole thing, right? So I'm going to take my function 4x minus 9. That's my f of x that you see on the chart. And I'm going to add 5. Okay, see how that compares a lot to what I have on that chart? This is my f of x, my old function, and I'm adding 5 to it. That's my plus k at the end. So when I do this, I can't simplify in the parentheses anymore, so I drop them, and I have 4x minus 9 plus 5, which actually gives me 4x, say it louder, minus 4. So that's my new function. This was a translation. I'm just going to go like this. That was 5 units up. Right? Okay. Nope, it did not want you to graph it. We are going to learn how to do these without looking at the graph at all. So then we don't have to waste our time graphing. They can just give me the function, tell me where to move it, I can move it, and I'm done.
So are the parentheses like absolutely necessary? Or can you just like... Will they be like important in the future?
Yeah, they're going to be important like reflections.
Okay.
They'll be really important. Your stretches and shrinks, they'll be important. Okay. Good. Okay. So part B, they are asking us, write a function h, so we're going to have h of x, whose graph is a horizontal translation 1 unit right of my original graph. Okay? Now a horizontal translation, I'm only changing the x. Okay? So when I write this is where your parentheses are important here. You got to make sure you put them in the right place though. I'm going to have 4 and then I'm going to have x. It would originally be minus h minus 9. That's my original function, but I'm changing the x, right? How far did they say they wanted me to take this to the right? Okay, So this is what h is. So when I replace that, I should have minus 1 on the inside. Okay? I'm changing, this used to be just x. I'm changing it by moving it 1 unit right. So now it's x minus 1.
Whenever you move right to left, you have to do that?
Yep. Right to left, that's what we're going to have to do to change it. Okay? Now, go ahead.
So negative right, positive left.
Basically, that's why I filled this in as h originally, because as you see on your chart, this is x minus h,
Yeah.
right? They told me to move it 1 unit right, which is a positive 1. So instead of h, I'm plugging in positive 1. Okay, now, let's say they would have said this was minus h. They said they want to move it 1 unit left. Well, that's negative 1. So I'm going to plug in a negative 1, which would end up making everything positive.
So negative right, positive
Yeah.
left.
Okay, so right now where we're at, with this going right, I have x minus 1 here. Okay. Can I simplify this expression? Yeah, what can I do with my 4? Distribute it. So I have 4x minus 4 minus 9. So my final answer, h of x, is going to be 4x minus 13. That was a horizontal translation, 1 unit to the right. Okay. Not bad so far, right? Okay, just pay close attention to your chart. So moving on to the next page, this one gets a little bit confusing. Moving on to reflections. Okay, so we take a look here on our core concept. We have reflections in the x, reflections in your y. Look at your chart. If I reflect in the x-axis, do I change everything or just what's my x's? Everything. Okay, it's on the outside of my function, so I would change my outputs, which would be everything. So let's do that one first. That's typically the easy one. So they give me my original function as f of x equals the absolute value of x minus 5 minus 4. Okay, so here's my starting function. They want me to write a function h, which is a reflection in the x-axis. Okay. And we just said I have to change everything, right? Because I'm changing the outputs. So, more parentheses. I'm changing everything. So I'm going to take a parenthesis, and I'm going to put the absolute value of x minus 5 minus 4. But I'm going to change the sign on all that. Okay, now this one sometimes isn't too hard. People don't always have to write all these steps down. Just be careful, because sometimes people end up with this negative inside this absolute value, and that would be incorrect. I take this negative, distribute it. I get negative absolute value of x minus 5. And then what? Plus 4. The nice thing about reflecting in the x-axis is you literally just go through your function and change all the signs. Okay, so for example, yeah, this is done. Let's say I have this really long quadratic function. Give me 1 second. Go ahead.
Oh, why wasn't the negative fraction instead of negative?
Because good question, it's already inside these grouping symbols by itself. Yep. So that'll happen once I combine these and take the absolute value, then that negative will go to it anyways. Okay. So for example, let's say I have a quadratic. I have negative 2x squared plus 3x minus 9. A reflection in the x-axis would be positive 2x squared minus 3x plus 9. go through, change all the signs. See, I just changed all the signs. I didn't go through any more steps here than I did here. It took me one step. I just showed you why it worked. Okay? With us? We good? Zach, you good?
Just waiting for it to get hard.
Okay. Here, I'll give you something that's hard to explain.
It's coming. Here it comes.
Here it comes. You ready? It's not hard, it's just hard to explain. Okay, this next one, reflection in the Y. This one's a little harder to explain because this one they want us to change our X, right?
Yes.
Okay, we have to change our inputs. So I'm going to take my original function, and this will be g of x, and basically what I'm doing, and I think the easiest way to explain this is think about what this graph looks like. Okay, what shape is an absolute value graph? It's a V shape, right? If I took it and reflected it, poor diagram. Okay, if I took that and reflected it without moving it left and right at all, it'd end up exactly the same, right? Okay. If I took it and let's say it's over here 5 units is the vertex, and now I reflected it over the y-axis, where is it going to end up? It's going to end up over here at -5, right? Everybody with me on that? Okay, it's going to end up over here. Okay, so before I moved it, oh, that's not working right. Before I moved it, I was to the right 5. After I reflected it, I was left 5. Okay, well, my original function, is this left or right 5 of my y-axis? Right. This is right 5, because remember it's x minus h always, so h is 5. It is currently right 5 units. If I reflect it, it will then be left 5 units. And the absolute value ones are hard, because all you're going to do is change this sign. Last class period, so this is your new function right there. Okay?
Wait, where's the first one?
It was our same original one in black. We're using the same function. Okay? Last class period said, well, but I'm changing my x, so I'm changing right here. Okay, it doesn't work on absolute value functions. Okay? If you were doing a linear function, this is not correct. Okay? This negative here is incorrect, because on absolute value functions, I'm reflecting and it's going to end up the same just on the other side. Okay? With a linear function, give me 1 second, Peyton, I'll get to you. With a linear function, if I had y equaled 2x plus 6, I would have to change the x to negative, and I would get negative 2x plus 6. Okay? Here you would change the x. Okay? But with the absolute value function, since you reflect it and it ends up back on top of itself if it's not moved left and right at all we're going to change is where it is left and right.
So that would be left in.
This would now, I originally was 5 units to the right and down 4. Now I'm down 4, but now I'm left 5.
So basically,
I reflected it in the
if
y-axis.
it's positive, then it's on, then it's in quadrants 2 and 3, but if it's negative, then it's in 1. Okay, yeah, forget about quadrant 3.
Yeah, you're right. Okay. All right, Peyton.
Positive, it goes left.
Good.
It's negative, it goes right.
Okay, this is, like I said, this is the confusing part right here. Because typically, they're telling us to change our x value. They're telling us to change our input, right? If you change your x here, you're going to end up with the wrong answer. Okay, so don't do that. We're only changing the number connected to x. Because, let's say this was just the absolute value of x, even if it's plus 7. Reflect it in the y-axis, what happens? Nothing. It stays exactly the same. Because it's not moved left and right. It's already on the y-axis. So if I take an absolute value on the y-axis, flip it, it's right back to where it started. Okay?
Up 7.
Same would be true with a parabola. A quadratic. Okay? If I reflected a quadratic, it's already left and right none. It's right in the middle. And I reflected it on the y-axis, it's going to look exactly the same. Right? You're not even going to know that you did it. Okay, so just be careful. Your linear one will change. Okay, that will look different. Because if it's linear, let's say it's linear and it's going up this way. Well, if I reflect it in the y-axis, now it's going down this way, right? Okay, so that one would work. That would be different. Okay, we'll work with some other ones that change also. Just be careful with it. Imagine the graph and what it looks like. Okay. No. You should be able to look in your textbook and tell that that's not it. Okay, flip the page. We still have to do horizontal stretches and shrinks and vertical stretches and shrinks. Okay. Take a look on your chart. Our horizontal stretches and shrinks, are we changing the inputs or the outputs? Inputs. So I'm only changing the x values, right? Okay. Now this is the next place you got to be careful. Look below where I have horizontal stretch shrink written. If they tell you to shrink by 1/2, I'm actually going to plug in what? 2. If they, notice it's the reciprocal. It's the reciprocal. If I stretch by 2, I'm going to plug in 1/2. Notice it's the reciprocal. So, if you're doing a horizontal stretch or shrink, and they tell you to do it by 7, you're actually going to plug in 1/7. Okay, so just be careful. The reason that is because for certain functions, horizontal stretch is the same as a vertical shrink, and a horizontal shrink is the same as a vertical stretch. Okay, but you got to be careful because there are functions where that is not the case. Yes, Olivia. Right, it's not the opposite reciprocal, it is just the reciprocal. Correct. But you can't, yeah, that would be a reflection if you throw a negative in there. It'll always be positive. Remember we talked last week where with a vertical stretch or shrink, bigger than 1 is a stretch, between 0 and 1 is a shrink. Bigger than 1 is a vertical stretch. Between 0 and 1 is a vertical shrink. Because if I multiply something by a fraction less than 1, it's going to get smaller, right? If I multiply something by anything bigger than 1, it's going to get bigger. Okay, kind of like what we did last year, geometry with dilations. Fraction makes it smaller, whole number makes it bigger. Okay? So, let's take a look here. We're going to do another absolute value function. They give me that the original function we are working with is f of x equals the absolute value of x minus 1 plus 2. Part A, they would like us to write a function g, so we're going to have g of x, whose graph is a horizontal stretch Now, to be a stretch, it's got to be bigger than 1, right? They want it by 5. Okay, but you got to be careful because I said horizontal. Okay, so what I'm going to plug in is actually not going to be 5, it's going to be 1/5 to just the x value. Okay, so this is what this is going to look like. I'm going to take the absolute value of, make sure I say this right. Yes. I'm going to put the x in parentheses because I'm only taking 1/5 times my x, minus 1, close my absolute value, plus 2. Okay, now the parenthesis isn't probably necessary there. I put it because sometimes you'll have other things with that x. I just like to always have a parenthesis just in case. Hey, maybe you don't like it. That's up to you. So my answer is going to be the absolute value of 1/5 x minus 1 plus 2. I took the parentheses out. Because I like parentheses. I like to use the parentheses to really show what I'm supposed to be multiplying it to. In this case, you probably don't need it.
Okay, but will we need it?
In the next case, you'll need it.
Oh my god.
So just like do press.
How many more cases do we have?
1. So you can stop complaining now.
Are we doing the whole
Wait, hold on, we're doing multiple cases?
No. That's not what she
I
means.
thought we said case, I was like,
She did. That's not. We have one more. Let's say scenario.
okay.
Okay.
He said case.
So, part B. This next part, they want us to write a function h which is a vertical shrink Am I going to give you a number less than 1 or bigger than 1? Less, because it's a shrink. By 0.25 is what they asked for. Okay. Now, a vertical shrink, as I look on the sheet, says I have to apply it to everything. Right? So what I'm going to do with this one is I'm going to take my 0.25, and then I'm going to put a parenthesis, and I'm going to do the absolute value of x minus 1, absolute value, plus 2. So now with those parentheses, I'm showing that I have to take that 0.25 and apply it to every part of my function. I'm applying it to the entire original function. Yes, Abby? Good?
Yeah,
Okay. Now I just distribute 0.25 times the absolute value of x minus 1 is 0.25 absolute values of x minus 1. Right? And 0.25 times 2 is 0.5. Okay, where did I confuse you at?
You lost me at point.
Do you want to change it to a fraction? Yes, I will never tell you not to change it to a fraction.
Is it easier to
I would prefer it in a fraction, but they gave me 0.25. Okay, if you wanted to change it to 1/4, I would never ever tell you not to, because I love fractions.
So, all you did was rewrite it, right?
All I did here,
I know,
I rewrote my function, and by the rule we have on our chart, says I need to take my factor times everything. So I put parentheses around it so I knew to multiply it by everything, and I distributed it times the absolute value, and I distributed it so I multiplied it by 2. And then I wrote what I got.
Are you confused because you can't distribute it to the absolute value? Yes. Okay, yeah.
Okay, yeah. Because once I know what x is, if I were to know what x is, I could take, let's say x is 3. 3 minus 1 is 2. Absolute value of 2 is 2. Now I'd take my 0.25 times that.
But you have to have a whole number.
Okay.
Okay, that makes sense.
No, I wouldn't have to have a whole number.
It has to be positive. It has to be a number.
No, it doesn't. Because it's got absolute value. It's going to turn it positive. Right, it's not going to have another variable. It has to be a number, yeah. Yes, Peyton.
So just don't change the absolute value stuff.
Yeah, if it's in the absolute value, don't mess with it. Just put it out in front.
Okay.
Okay? No, stop asking that. All right. Looking at example 4. Okay. Doing multiple transformations in one. They give me we're just actually going to use our parent function here. F of x equals x. Okay. So I just have a linear parent function here. And they want me to take this graph and they want a horizontal stretch I believe they say stretch. Yeah. By 8. On this one, I'm doing a different one than what you guys have a little bit, but it's the same concept. And translate it 10 units down. Okay. Going to our horizontal stretch, does that apply to everything or just the x?
Just x.
Just the x. In this case, does it really matter?
No.
No, because it's just x by itself anyways. Okay, so is that correct?
No.
Why? Horizontal, right? Horizontal, I should have done not 8, but 1/8. And if you remember right, our translations, right, Zach? Good. Our translations up and down are very easy because I just do what to the end of the problem? I just take whatever I have, -10, and I just tack it on the end. Okay, now, keep in mind they might not all be that easy, right? Okay, I only have so many examples here. I could go and do your homework problems for you, but that wouldn't do you any good. Okay? But just understand that you can combine multiple transformations into one problem. Okay? There is a word problem there. For sake of time, I'm not going to do it right now. We might talk about it tomorrow after our quiz. Okay? Sorry, the quiz is over sections 1 and 2. Also, keep in mind that there is only 4 sections in this chapter, so we will be having a test coming up.